All right, good morning. Let's go ahead and get started. We have two things planned depending on the track that you are in for our learning lab this week. If you're in tracks A or C, we're going to do our Unit 3 test review. So on your pacing guide, that's where you should be at this point, getting ready to take the Unit 3 test or having already completed the Unit 3 test. So we're going to review questions from that test on here, so that if you haven't taken it, you're prepped for it. And if you have taken it, you have the option of revising some of your answers or retaking the test if you feel that it is necessary. And that'll be for tracks A and C. For track B, what we're going to do from 8:15 to the end of the learning lab is a lab that was done previously by track A and C students regarding sugar solutions and an online lab that we'll be working on. So at 8:15, we'll conclude the session for tracks A and C, and then the only students that would have to stick around would be those for track B. Just as a reminder, if you ever need just personal help with any assignment that you're working on, or just want to talk about the course, anything at all, remember that there are office hours every day, 3:30 to 4:30 p.m. There are days when I'm sitting there and very few students come, so I do have that freedom to give you the undivided attention. Good. Yeah, please feel free to drop by 3:30 to 4:30 p.m. every day in this classroom. Okay, let's go ahead and get started. So for Tracks A&C Unit 3 test review, again, just like I always do with this reviews, our learning goal is to review for the Unit 3 test. So what I've done is taken questions directly from that test, and all we're going to do is cover them right now. So let's just go ahead and get started. As I'm going through the questions, if at any point you have any concerns or questions, please feel free to just type them in the chat box. I have that open so that I can keep looking at it just in case there's something that I need to address. All right, so what you did in Unit 3 was study acids and bases, and you're going to get questions that ask you about the different properties of acids and bases. You're going to get questions that ask you about ways of calculating pH, or determining what it means to have a pH. So in this case, you're being asked what substance gives lemons and pickles their sour taste, and I see in the chat box one of the answers says acid, and that's correct. So remember, one of the properties of acids is that they have a very sour taste, or they give things that they consist or are found in a very sour taste. And that's the answer for this one. What happens when an acid reacts with a metal like magnesium? Keep in mind that when this takes place, acids reacting with metals, you have a bunch of different things that can happen. The main thing that happens when a metal reacts with an acid is that the metal starts to become corroded. And so what you would see in this case would be that the answer would not be that the metal becomes polished, because corrosion is the opposite of that. The acid is not actually converted to a base necessarily. What ends up happening is that you create this reaction called an oxidation reaction, in which electrons get transferred between the metals and the acids. And so really the best answer for this question would be that a chemical reaction occurs between the acid and the metal. Okay. Yeah, that's a good idea. Don't throw it on your car. If you've ever heard of acid rain, if you live in an environment where there's a lot of pollution, a lot of smog, what ends up happening is that that smog gets combined with the rain when it rains. And what it produces is this thing called acid rain, because the smog turns the rain into a very acidic substance. And what it does, if the rain hits your car, it starts slowly corroding the paint on your car because of that acid rain. Yeah. So if you live in a city maybe like LA, right in downtown, or New York, the rain isn't strong enough to burn your skin, and you really need this to happen over a long period of time. So over a long period of time, the rain constantly hitting your cars, eventually the paint starts to wear thin. So no, it doesn't necessarily hurt your skin unless you're standing out there 24 hours a day and it's raining all the time with acid rain. Exactly. Main component of acid rain is sulfuric acid. Okay, what type of reaction occurs between an acid and a base and results in the formation of salt and water? So in this situation, you have an acid and a base reacting, and if you ever get an opportunity to work in a lab, what you'll have to do at the end of your in a chemistry lab, what you'll have to do at the end of the day is called neutralizing all your chemicals, because by the time you're finished working, all your chemicals have different pHs. So you have some that are bases, you have some that are acids. So what you do is if you have something acidic, you add a base to it. And if you have something that's a base, you add some acid to it until you neutralize it and you get all of your substances to have a pH of 7. So in this case, when you have an acid and a base and you neutralize it, you form salt and water. This is what's called a neutralization reaction. And then once you've done this, you can pour your chemicals down the drain because they have the same pH as water. Okay. Which of the following is a Bronsted-Lowry acid by definition? You studied two main definitions of acids and bases. One was called the Bronsted-Lowry definition. The other was a Lewis definition. So in this case, anytime you have a Bronsted-Lowry acid, remember that acids are categorized as hydrogen ion donors. Another way you may hear it in the future is proton donors. So acids are anything that will donate hydrogen ions. So if you can think of an acid like hydrochloric acid or hydrofluoric acid, those acids are hydro because they have an H in front of them. And it's that H hydrogen ion that gets donated to different substances. So your answer would be any substance that can donate hydrogen ions. Okay. Next question. According to the Bronsted-Lowry definition, so that same definition we were just talking about, which of the following is formed when a base dissociates in water? So it's always going to be the opposite. So if you have an acid and you dissociate it in water, you produce a conjugate base. If you have a base and you dissociate it in water, you produce a conjugate acid. Oh, that's actually highlighted incorrectly. So this should actually be wrong answer. A base dissociates in water. The right answer is conjugate acid. So just keep that in mind. I highlighted the wrong one there. Sorry about that. So remember, it's always the opposite. Base leads to conjugate acid. Acid leads to conjugate base. And conjugate really just means opposite. Okay, which type of substance is an electron pair donor? Now we're going to our second definition. So you started with the Bronsted-Lowry definition, which defines acids and bases as either proton or hydrogen ion donors or acceptors. When you get the Lewis definition classifies these things as either electron pair donors or electron pair recipients. And it's actually the opposite of your Bronsted-Lowry. In your Bronsted-Lowry, the acids were the donors. In your Lewis definition, your bases are the donors. They're donating the electron pairs. So the Lewis base is the donor. Now you're asking why? Let me give you a good example of why. So let's look at something like HCl. HCl is an acid, right? Now, if you react it with water, here's what can happen. What the HCl is going to do, according to the Bronsted-Lowry, is donate its hydrogen here. So it's going to give it to the water. So the water is now going to have 3 hydrogens, and because it accepted a hydrogen, it gets a plus charge. Now what's left is the chlorine, and because it lost its positively charged hydrogen, it now has a minus charge. So keep in mind that the HCl here acted as a hydrogen donor. Now, in order for it to get that negative charge, the water had to give up its electrons because it accepted the hydrogen. So notice, because the chlorine got a negative charge here, it also acted as an electron acceptor. So it's always going to be the opposite. The acid is going to do two things. According to Bronsted-Lowry, it's going to donate the hydrogens. According to the Lewis definition, it's going to accept the electrons. Can you refresh me on how we know that the chlorine had a positive charge on the? So good question. Initially, it did not have a negative charge. Initially, the HCl was uncharged because if you separate them just on their own, the hydrogen on its own has a plus charge. And this is just according to your periodic table. Remember when we reviewed the periodic table, everything in group 1 has a +1, everything in group 2 has a +2, and then you go all the way to the other side, everything on that group 7 has a -1. So because the hydrogen has a plus and the chlorine has a minus, when you combine them, the charges cancel out and you get just a neutral HCl. But because you're reacting that acid with the water, you're splitting them back up, which is why the hydrogen leaves, gives the water a plus charge, and the chlorine stays on its own with a negative charge from those electrons. Chlorine just naturally on its own always has a negative charge. Everything in that group always has a negative charge. Chlorine, fluorine, bromine, and iodine, etc. Okay. So remember, it's always the opposite. Acids are hydrogen donors, electron acceptors. Bases are hydrogen acceptors, electron donors. All right. Let's move on. 15, what is true of acids? They have a pH below 7, they have a pH above 9, or they have a strong affinity for hydrogen ions. Correct. Remember, acids, anything from a pH of 1 to just before you hit 7 is an acid. Anything a pH right above 7 until 14 is a base. So the answer is that acids have a pH below 7. What is the pH of pure water? Pure water is interesting because it is unique in that it's not an acid and it's not a base, it's neutral. So it's right in the middle of that pH chart. So the pH of pure water is 7. It's a neutral substance. And we have one more. Now let's pay attention closely to this one because this question kind of summarizes the main different definitions that we've covered in this unit. Hydrochloric acid and acetic acid are both acids. Hydrochloric acid completely dissociates in water, whereas acetic acid does not. Which of the following statements best describes both acids? The big thing here that you want to focus on is this term here, complete dissociation. Yeah, so remember this concept. A strong acid will always completely dissociate, meaning that it will give up all of its hydrogens. Whereas a weak acid will not. A weak acid will only partially dissociate. So anytime you see those terms, keep in mind a strong acid completely dissociates, whereas a weak acid does not completely dissociate. So in this case, all of you that were typing are correct. The correct answer is C. Hydrochloric acid is a strong acid, and acetic acid is a weak acid. And acetic acid is hopefully a weak acid because it's often the type of acid that's found in something like orange juice. Okay. I see some typing there. This is the heart of all of the questions that you should run into in your Unit 3 test. If you have any specific questions, I'll take them right now really quickly. Otherwise, you can ask them during office hours. So a weak acid is one where it does not completely, aramid does dissociate, but it does not completely dissociate. So some of the molecules still hold on to their hydrogens. Mhm. I see some typing, so I'm just going to wait in case there are other questions. Cool. All right. So if you are in track A or C and you do not have any questions regarding this test, you are free to log off. If more questions come up, please send me an email, or you are welcome to come to office hours 3:30 to 4:30 every day. Bye, Christian. You're welcome, Jaden. You're welcome, Raylan. Bye, Rachel. Bye, Jillian. Have a great weekend. Bye, Raven. Bye, Isabella. Bye, Dana. You're welcome. Okay. So now the remainder of you should be all in track B. If you are in track B, it means that we are at the point in your pacing guide where we're doing the sugar and salt solutions lab, virtual lab, because you are in the middle or almost finished with Unit 2. So what I'm going to do right now is I've uploaded the document here that you're going to be working with. I'm going to review it. And after I review it, what I'm going to do is give you the opportunity to work on it. I'm not sure whether we'll have enough of you to form a group or more than one group, but if we do, then we'll do that. So real quick, what you're doing here is visualizing mixing with sugar and salt solutions. And what this is a simulation using that same website we've used before. Your learning objective here is to describe the process of solution formation for salts versus molecular compounds. And you want to identify the difference in an ionic solution and a molecular solution. So your directions are going to be to open the sugar and salt simulation. Now this link is not very clear because this will just take you to the regular PhET website. So I'm going to provide a different link down here in just a minute that'll take you straight to the simulation. And what you want to do is go through steps 1 through 9 here, and then they continue on pages 2 and 3 all the way to steps 21. Now, this does not have to be completed during this specific learning lab. It just has to be completed by the end of the week. The benefit of it is that you have this time to work on it so that you can complete it now if you can. And when you're done, all you're doing is writing all of your answers on a separate document or in an email and emailing them to me to get credit for this. Okay? So let me provide the link, the specific link to the simulation I'm talking about. I'm going to type it right in the notes here. So this link that I've typed in the notes will take you straight to the sugar and salt solutions. You'll then be able to work on the lab there. We have enough students to where we're not going to split up into groups. We're just going to all kind of be one group so we can ask questions and talk about these responses in the chat box here while you work. In the meantime, I'll be still logged on here in case you have any questions you can ask me. Before we actually start on this lab, are there any specific questions? Just to make sure that we're good, if you don't have questions, if you could just type no in the chat box, please. Okay, so then please go ahead and start working on the document here, on all the questions. You are allowed to move the document up and down so that you can see what questions you want to work on. If you have any questions as you're going through the lab, please feel free to ask me. Type it in the chat box and I'll go through whatever concerns you have with you. We'll work on this until 9 o'clock, then I'll have to log off. And at that point, you'll be able to work on it on your own. And again, just make sure you email me the responses before the end of the week. Okay, go for it.